Hope it doesn't like screw up or something. All right, you are now live. Cool. There we go. Close my door. So. Okay, here I'm gonna. One second here. Hold on, I'm setting you down. Okay, so you can hear me? All right, cool. I sound all right.
Yeah, if you want, I'll stay on for like a minute or two. Type in the chat.
What's that? Type in the chat and what?
I'll type in the chat. I just don't get to go. By the way, we're looking right now. Right now.
No, okay. Let's see here. All right.
I can hear myself.
What's that? What do you say?
I can hear myself in the background.
Oh, okay. Yeah. All right. There we go. So hide that. All right. Oh, look at that. Okay. All right, I think we're good to go. Good morning, everyone. This is Kenny Hart with Geometrics Tech. Looks like it's 11 o'clock, so we'll go ahead and get started. Get done here before lunch break goes to lunch. So let's see here. Sure, we're good to go. Okay. Kind of like you guys, can you guys hear me all right? You can use the chat, just let me know, and then we'll get started here. All right, great. Looks like you guys can hear me. So yeah, we'll go get started. All right, so again, I am Kenny Hart. I'm the sales engineer with Geometrics Technologies. I'm one of our applications engineers. So I've got a very brief PowerPoint I want to go through just to give you a real quick overview of what we do. So we'll go ahead and get started there. So let's kick this off. All right, so Geometrics, some quick background information from us. We were founded in 2003 by Dan Perot, our CEO. Dan was an aerospace engineer and has been in this field now for over 20 years. I myself have been with Geometrics since 2011. We offer services, so 3D scanning, reverse engineering, inspection services, 3D printing, as well as we sell the products that we use. Over on the right here, you can see we've got our main list of customer companies that we represent. A few of our bigger clients, we have a very diverse group of partners, and these are some of the bigger names that you guys might recognize. But to jump right into the presentation, the 3D scanners that we use mainly are going to be our HandyScan Black Elite. Everything's from, we use Creaform scanners. We partner with Creaform. We use the HandyScan Black Elite as well as the MetraScan 3D. Both very similar scanners. One uses the MetraScan uses a tracker system. They're both handheld, but the tracker gives it a much larger field of view, which I'll show you. This winglet part, we actually use that scanner for it. But to give you the scanning workflow here, so we start with the physical object. We use one of our scanners in our lineup. We get that scan data, and we either go to inspection, so we apply that scanner to the CAD file for an inspection report, or we're going to do what I'm going to walk through, which is create a 3D model. With that scan, we're actually going to bring that into Geomagic Design X. So if you're familiar with Design X, it's a specific reverse engineering CAD program. So this is the step in between the scan and what your end use software would be it use SolidWorks, Creo, CATIA, any of that stuff. So the big advantage with Geomagic is if you've ever tried to bring an STL into your native CAD formats, it really bogs the computer down. They can't handle files that well. We've got mesh editing tools and repair tools, and we also use automatic surface and solid extraction tools, which I'm going to really go into. We're going to use a lot of those in this presentation to generate that file. So if you want to see, you can jump over to our website, 3dscanningservices.net, and go to case studies. And we actually have a case study written for this specific part, where we scan the part that wasn't created anymore, unobtainable, took that scan and created the CAD file from it. We also have on our YouTube channel, if you search on our YouTube channel, we've got that as well, 3D scanning winglet fitting. So to get started, there we are. We got our software. This is Geomagic Design X. This is the scan of that winglet fitting that I brought in. Okay, so I've gone ahead, just to save us a little bit of time, I've already aligned the scan to our coordinate system, and I've broken our mesh up into what's called a region. So we've got this region fit tab here that will go through, and it will analyze all the surfaces on the part and tell us whether it thinks they're planes, whether they're freeform surfaces and such. So I'd like, this is going to be sort of a walkthrough tutorial. Hopefully this will help any of you guys that are using the software as well on maybe some models that you're trying to complete, some issues you're having. So so feel free to chime in with any questions as we go. I'll go through and answer any of the ones you got at the end. So let's get started. With this guy, I did mention with Geomagic, we do have some automated feature extraction along with all the other standard CAD modeling options that we can use. I'm going to start this with the very basic 3D, or called a mesh sketch. So it's just like a sketch that you would set up in something like SolidWorks. You select a plane, but what this allows us to do is drag a cross section through our mesh and project that cross section back onto our base plane. The reason I'm doing this is I align this part based off of this bottom plane here and a couple other features. So there are some features that I want to ensure are square to our coordinate system. So if I rotate my part around here, you can see it took that pink polyline and it projected it onto that plane. So forgive me, I'm going to rotate this around. Okay, and I'm going to sketch a line. So what this sketch line can do is I can drag it and I can snap it to one of those pink reference polylines. We'll get into this a little more later, but you can also highlight any of those polylines and snap a best fit line to it. So what I'm looking for here is to go ahead and sketch the couple surfaces that are perfectly perpendicular to this sketch plane here. So one is the bottom. I'm going to go ahead and make that a 0 offset from my UV coordinate system. And the other one, if I zoom in really far, I can see I've got this slight angle here. I'm going to highlight that. It's going to put a line on there. I'm going to fix it, drag it into my part, okay, and then use the trim tool to make both of those corners. If I take a look at the rest of my part, I can see everything else is drafted and they're all different drafted angles. So it is something I have to go and create each surface as I go. But the other option I can do, the other surface I have is this vertical surface here. So again, snap, click on the pink reference polyline. I'm going to go ahead and constrain this to be vertical. Okay, snap it up, and we're rolling. So let's exit that sketch and extrude. With this, what I'm going to do, I like to if I can, model with surfaces, but because this part is a whole bunch of different drafted angles, it's very hard to do a one extrude. So what I'm trying to do is get to a solid body, or sorry, say model with solids. I'm trying to get to a solid body as fast as possible. So I'm going to be applying surfaces to all these faces so I can trim them into a solid. Okay, so we've got those couple extrudes there. That's good to get us started. What I can also do to start making planes, I'm going to hide those two, and I'm going to hide my front, top, and right planes. I don't need to see those. Is I have these surfaces here that the software recognizes are planes. I can come up in my Create Surface and Create Solid tab. We have a primitive option. So I can click Surface Primitive. I can choose to extract a plane, and I'm going to select that region right there. And you see it's going to apply a plane to that face. Okay, so for all the users who actually have this software currently, Control Spacebar is a shortcut for bringing back the last tool. I'm going to go ahead and use that, hit Control Spacebar, brings back up my surface primitives, and I can choose my surface. So we'll do one more here. I've got this plane. Okay. And again, I want all these surfaces to extend past the boundaries of my part. This one doesn't, it stops a little short. So there's a few things I can do to fix that. I can just go and do an extend surface and pull it past the ends of the part where I can trim it back to the end faces. But if you've noticed in your tree over here, we've got it doesn't actually just like place a plane in there that we can't edit. It gives us a plane that's normal to our region. Okay, and then it gives us a sketch, so it gives us an automatic sketch, and then it extrudes it. It gives us a surface extrude. So we can go and we can edit any of those. So for one, I can go into my surface extrude, pull that out, okay, and fixes that, and I don't add any other features to my tree, which will save you some processing power down the road. I can also go to my sketch. I'm gonna right click, fix that. I'm gonna drag the edge just into the part a little bit. Okay, just so I make sure that it bisects this surface here. All right, there we go. So we'll bring up a couple more. We'll do same thing, surface primitive. Okay, and then a surface primitive. And I'm gonna break this kind of up into groups just so it's easier to see what's going on. All right, there we go. There's our last one we're gonna do for this group. And enter the sketch. But I want to break it up into groups so I can start trimming them. So I don't have 100 surfaces to trim up. We're just going to do it little by little. So using a trim tool, just like you would in your standard CAD software, we're going to select those surfaces and then select the faces we'd like to keep. Okay. There we are. So now we've got that block done. Okay. And then if I show these surfaces here, there we go. I can trim those up as well. Just 1, 2, 3, and 4. And what I want to end up with. All right, there we go. There's a few more planes on here. I'll start working my way around. But what I want to get to next is a surface. When I hover over this guy, I can see it's a revolution. It's not a plane. So if I try and fit a plane on that, it's actually curved. If I turn the colors off, you can kind of see that these two surfaces have curved edges. There's a couple ways I can do that as well. Expanding on our automatic surface extraction, we can go to what's called a mesh fit. Instead of creating a geometric surface, it's going to create a best fit surface patch on this guy. All right, so I'm going to grab that surface. I like to err on the side of smoothness. I'm going to crank my smoothness all the way up. I want that to be a really nice surface. And I click my next stage button. So what this does is gives me a preview. Over on the right here, I've got this accuracy analyzer pulled up. Okay, if I click the deviation for body, what this does is it analyzes that surface back to the scan data to make sure I can do this every step of the way to make sure that I'm accurate to my CAD model. Okay, let's see here. So now we're going to go ahead. This looks pretty good. If I hover over the part, I do have a little bit of blue here, which means the scan data is actually coming out of my CAD face a little bit. If I hover over it, it's about 6 thousandths. Right now, everything green is plus or minus 4 thousandths. So on a part like this, I'm pretty happy with that. I don't want to, I could give up a little bit of smoothness to try and pull that in, but that's good to go there. I'm happy with the way that surface looks. All right, so we're gonna go over to this side and do a very similar process. We're gonna do an automated surface extraction. Notice it's a free form, but instead of a mesh fit, we have the Loft Wizard, which is right next to it. When I click Loft Wizard, this is going to generate an automatic loft. So it'll give us an automated surface, but it gives us much more control over what that end result is going to be, not just a smoothness slider bar, essentially. So I'm gonna, again, make sure the extents of my loft kind of extend out of the face, okay? And with a loft, I like it to be smooth, and I like to use as few surfaces as I can. So I'm gonna start with 5. That should give us a pretty good result. All right, so there's my automated loft surface. You can see it created a few splines here with 5 nodes on each. Notice right here. And we've got these 5 bisecting planes. Again, turn on my deviation for body, and this is where this software really shines. So instead of having to just maybe guess that I got that surface right, I see live what happens when I play around with my splines, play around with my planes. So I can really tighten this surface up very quickly. Maybe 5 points in each spline, 5 of those nodes is a little too few, so I'm gonna bump that up to like 9. Not make it too many, but this may give us a little bit better result, okay, on our surface there. So you can see it tightened up quite a bit. It gave us a few more points laid across that surface. What I can also do is I can drag a copied plane into my areas of highest deviation, and it'll again put another section within that loft. Do that over here, and that's really gonna pull everything in. All right, so we can tweak this around a little bit. I can pull this one here. It might give us a little bit offset here, so maybe we need one more section, and we end up with a surface that looks really good. Again, if I hover over everything, 7 thousandths is that high spot, that's fine, or low spot, I should say. Everything else you can see is really tight. The numbers scrolling across my screen there on my mouse. So we're gonna accept that. And so very quickly, we created 2 complex surfaces there. This guy's a loft, so I do have to, there's no extrude to extend my surfaces. I will use a surface extend to pull that out. I don't need it that far. We're gonna tighten that up a little bit. All right. All right, I'm gonna apply the same thing to this face here. So again, Loft Wizard, we're gonna go back to 5 sections. Okay, pull these in a little tighter. All right, check our deviation. All right, that looks perfect, didn't have to do anything. Click the checkbox, and then hide this, scan, and use our extend surface one more time. All right, I'm gonna go a little bit further with that. Okay. So this is kind of what we're doing on this whole part. At least around the boundaries, we're finding ways to apply surfaces to this before we trim it up. So you see this surface here. I'm going to go back, apply another plane to it. All right, it may be kind of small, so just because of the boundary, that region kind of drives the width of it. So again, I'm going to pull it out a little bit. Okay. And I think we have one more mesh fit we can do. Yeah, so this is a free form, still seeing it as slightly curved. So again, mesh fit, crank that smoothness all the way up to max, just to make sure I don't get any ripples in the surface there. All right, so let's take a look at what we got. We have surface there, there, and there. So I'm going to trim those up now. So surface trim, 1, 2, 3, and 4. All right, and then select the surfaces I want to keep. So 1, 2, 3, and 4. All right, so we've got a front, we've got a back. Let's see what else we've got. Let's go ahead and trim these 2 up. So we've got a whole back surface here. Okay. Now we want to cap it off. We've got a couple left, so I'm just going to go back to surface primitives, plane extractions. There's 1. 2. And I think that's everything. Let's take a look. Okay. Oh, and then one more, this surface right here. We'll get that here in a minute. All right, so we're going to do a trim, and that'll should give us the entire boundary of our part. All right, so 1, 2, 3, 4, 5 surfaces. All right. What I don't want to do is trim all these up at one time. I like to do intermittent trimming. That way I don't have a whole bunch of little pieces, where all the surfaces trim all of each other. Makes it a little easier to see what's going on here. Okay. I do want to make sure that those are all trimmed up nicely. You can see I've got some overhangs. That's fine. We'll trim those back. A real quick way to do that, I like to use the sew tool. And that tells me if I have any gaps in my surfaces. That all looks pretty good. There's one there, but it's outside of the extent of my part, so I'm happy with that. All right, so we're almost ready to bound this guy into a solid. So I've got a few more side surfaces to do here. All right, so again, just use surface primitives. You can see the software just very quickly, instead of having to go back and try and measure each one of these angles, hoping you got that measurement right, maybe if you have calipers or something like that, calipers, compasses, any of those kind of gauges, we can just apply that surface directly to the scan. There's no error stacking, nothing like that involved. And we know it's right. We can always go back to the scan that we have here in our field of view. All right, so there's the first set there. So let's trim those up. 1, 2, 3, 4. And once we get done with this, we're going to get into, we got some solid model extraction features, which are really cool. All right. There's one side. Now we're going to do the other. 1, 2. And this plane right here. Okay. There we go. All right. So last side, and now we have everything we need to make this a solid body. So this is very similar. We'll just go right into the trim surface. Again, same thing. We're just selecting all 3 as a tool. Some softwares, I know SolidWorks has a trim and merge option, but it's the same thing. They just integrate it into one tool here. But I'm going to use all 3 of those, select all 3 sides, and what we should get is a resulting solid. There we go. Okay. What I like to do here, accuracy analyzer, just like we've used in while we're making features, we can turn it on and we can just go ahead and double check. We got some areas that are a little higher, but again, we're talking 5,000, 6,000. It's nothing crazy there. If I bump this up to maybe a 10,000 band, you can see there pretty much everything is green. We got some areas that we still need to cut out, and then we have this you see this blue here. That's actually a radius. So if I turn that scan on, a very neat function within the software is this fillet tool. So it works just like any other fillet tool. You click on the edge, it makes a fillet. Let me go ahead and make that something pretty big. That way we see a change in it. But what we do have here is this estimate radius for mesh. If I click that, it's going to project that corner up to the scan and give me a best fit radius there. So I can see there 0.52644. I'm going to go ahead and make that 0.525. Okay, so we're taking a little bit of liberties there with the as built versus how I want it to model. Maybe the radius is a little off from what it should be. I have the freedom in this software not only to place planes and things like that how I want, but to also dimension them. Okay, so we're at the solid. Notice we got these through holes we need to cut. This is where this starts to get really cool as well. I've got these through cylinders. It recognizes those holes as cylinders. We're going to go into our Extrusion Wizard. So we haven't used this one yet. Okay, and what the Extrusion Wizard does is it creates an automatic cross section of an extrude and extrudes it at a certain amount. We can do solid merges, cuts, things like that, all within a couple of clicks. So what I do is I select the sides of my extrude, which are all going to be these cylinders. And actually, excuse me for one moment. What I like to do, it does make sure that everything works extremely reliably, is I go ahead and give it a vector, an extrusion vector direction. So what I'm doing right now is extracting a vector, a center vector from the center of that axis. You can pick any one of them, all right? Because notice they're all kind of off axis from, if I were to put a normal on this surface, they're all off axis. There's nothing, you know, they're not straight compared to the rest of the, to that surface. So I've let the software tell me what direction that center vector is. And now I can go into Extrusion Wizard, again, grab the sides of those cylinders. All right, I'm gonna leave top and bottom empty. We're gonna do a solid cut, okay? And I'm gonna check through all. So when I click my next button here, all right, you can see there it's created 6 extruded cylinders. And when I click the checkbox, it should follow through with that cut. And there we are. And again, just like before, it doesn't just make the cylinders that you can't edit. We can go right into a 3D sketch, or sorry, a mesh sketch. We can dimension, we could do anything here. So it made that circle 0.45. I can make the, maybe make that a 0.45 even. Constrain all of those to be the same. We can dimension between. So we let the software do the heavy lifting for us, and then we can do all the fine details in between. So we'll do that same exact process on the other ones here. Okay, so again, Extrusion Wizard, choose let's do our vector first. Okay, then we're gonna do Extrusion Wizard, click our side. So this time we have 10 cylinders. Okay, custom extrusion direction, that vector 2, and we're gonna do a solid cut through all. I'm just gonna click the checkbox. And there we go. Okay, so we're good to go. All right, we got our holes cut. Last couple things we can do. We have a few extrusions. We can kind of do the same process with these side holes. I'm going to do these side plates here. All right, so let's hide a couple of the planes that we're doing, or that we've got already made. Okay, along with those vectors. I don't need those anymore. Just simplify our view a little bit. So I can do another mesh sketch, kind of like what I did at the beginning. I can do it directly on a region surface. So I don't have to have a plane already made. I can just select, you see it's got that flange here. See, this is a plane. I can start a mesh sketch right on that, okay? And then I can drag that cross section. Again, I want to drag it into my part a little bit so I get a nice cross section through the side. Okay, make sure it's the same on both. And then I also want to make sure I got good holes there because I'm going to sketch those in. So I have this other option. Instead of an offset, it's called a silhouette, and it creates a bounding box. So every contour within that box, it's going to project up to my sketching view. All right, so we're going to click that. And then I'm going to use my, where is it at here? Rectangle tool. And I can either click and put lines right on, each of those pink reference polylines again. Because these look to be pretty square to my coordinate system, I'm just going to draw a rectangle, okay? And then round it up there, or snap it up to my reference polylines. There we go. Circles are just as easy. We're going to click right on that circle, and it's going to place a best fit circle on each of those. All right, again, we can go in, select each of these, dimension them how we want. If you want to make those an even 0.1, we can. We can make all the small ones an equal radius. Okay, and then go up to the other side, same thing. All right. And then for this extrude, again, this is a little more of a manual option, but I can click extrude. So it's very similar to what you would normally do in a CAD program. I'm going to show my region, and I really like this option. We sketched on the top of that region there, right? So if I turn it over, I can drag it down, and it will snap to the bottom. It'll give me a length value, so 0.204. So maybe it's 0.2, maybe it's supposed to be a little oversized, or 0.205, something that's kind of a round number. We'll go ahead and choose that. click the checkbox. All right, I could have gone ahead and merged it there, or I can merge via our Boolean tool. Okay, there we are. All right, last thing I do want to show you, you got a couple of the extrudes we could do, but another automated extraction tool is going to be the auto or the revolution wizard. Very similar to the extrusion wizard, but works on a revolve. So this guy, you see it broke it up into a few different regions here. So target, I'm going to click the regions of my revolve. Okay, we'll go ahead and leave it as a solid merge, and then I'm going to click the next stage icon. All right, so in next stage, it does let us play around with our underlying sketch a little bit. So if I zoom up, you can see there, it doesn't quite follow the scan. It makes this as a round. So I'm going to turn my resolution up. Let's bump it up to there and see what happens. All right, that looks pretty good. It actually gave me a round in there. See if it'll do it on the other one. That's all right. We'll go ahead and check that. Okay, and go ahead and add our own round. Let's see if 0.1 works. That looks pretty good. There we go. All right, if I take a look, I'm suspecting it didn't connect it. Yeah, so it's not quite connected yet. I could use a move face on that bottom face there and pull it down. But again, I've got an underlying sketch, so I'm just going to double click that sketch to go in and edit it, pull it into the part a little bit. All right, and there's our revolve. Okay. So that's most of the part. I can do one more sketch here to get these cutouts. If I look at these here, I can see that these holes are normal to this plate here. So I'm going to use that as my base sketch. And again, I'm going to do one more mesh sketch on that surface. And I'm going to pull my cross section way up here to get a really nice cross section of all four of those. Okay. Hide my mesh. And here's where I'm going to use my line extraction a little more, my automatic one, because I don't know what angle that is. It looks to me like these are all the same line, and if I click all of them, I can see that that's true. So I've expanded that line across all four of those sections, so they're all going to be collinear. Same thing over here. It doesn't see this one as a line. I can't click on it. It looks pretty good already, but I can window in dotted lines, and it'll include that in the best fit line. Okay, and then I'm going to create a line above and below that to cap it off. All right, so we'll trim those up. There we go. And then I want to also create the junction line. So I'm just going to use the one, copy it to all the different locations. There we go. So there I'm holding control and clicking and dragging on the line, and that makes the copy of it. All right. And then trim all that up. I'm using the power trim here so I can just click and drag. Anything overhanging, it's going to cut. All right. There we go. Last thing, you can either do these radii in the solid phase. So once you go to the solid body, you can click on the edges, or you can go ahead and put them in right here. I'm just going to go ahead and add them. And again, you can dimension anything in here, right? We can make those an even 0.5 inch radius. I can make that whatever distance I want there. I'll leave that for later. Right now, I'm just going to go ahead and create all of my radii. All right. So on the radius in the drawing, if you notice, I can click and hold. So if I click on one line and click and hold my left mouse on the other one, I can drag the radius up to match. And then from there, I can fine tune that number. So it gives me a very quick and easy automatic kind of guess of what that radius is, a visual guess. And then you can fine tune that number later. All right, there we go. Done with that sketch. We're going to exit that, and this is going to be very familiar. Same process you would use if you were modeling this part from scratch, other than we have a 3D scan that we're actually working from. So we're going to go into extrude, pull that out, click cut, Okay, there we go. I think we're just about done. The last step we can do are these side cutouts. I'll do one because they're both done the same way. Okay, but I've already got these side surfaces, right? They're already created, so I don't want to create those again and do some sort of extrude that would give me a split face. What I'm going to do is go right to my surface offset, offset each of those, again, using control spacebar between them so I don't have to go back to my tool every time. Okay, I'm going to hide my solid body, and I'm going to extend those quite a bit. So let's extend that guy into the body a little bit, because I want to extend them as far as that hole is deep. Okay, and extend this bottom surface. If I turn my mesh back on, I can see I've got my plane that kind of terminates down there, and I also have a plane here. So we're going to go, first tool we used, or second tool was this surface primitive. We're going to use that. We're going to hit control space bar again, use it on this plane. All right, and if I hide everything there, that's what I end up with. So this guy, I'm just going to run just because it's easy, run a surface, extend surface. We're going to trim all those up. Okay, and that's going to create our cutter tool. There we go. Cut that out of our solid body. All right, let's see what we got here. I'm going to go back and use my sew tool, make sure that, oh, there we go. Let's go back in. Something didn't trim up quite right, so it's because those aren't reaching all the way through. So let's do go back to my surface extend, pull it out just a little bit further. So those weren't reaching all the way to the back of the part, all right, or back of that hole. And there we are. All right, let's run through our trim surface again because it did not select the surfaces I wanted. No problem here. All right, instead of that guy, we're going to select the back. And now we should be ready to roll. So let's click that as our tool body. Click the winglet as our target body. And when I click the next stage, it's going to give us our selection, whether we want to keep the outside or the inside. Obviously, we want the outside. And the only thing left is to add some radii. So if I click my fillet tool, all right, obviously that's not the right radius. If we look at the mesh, click our estimate radius, bump it up to 3.3994 inches. I'm going to make that an even 0.4. I'm going to select each of those edges. Let's go ahead and filter our edges. Okay. And then last step, let's do this bottom one here. 0.3522. So let's make that a 0.35. All right. Like I said, there's one on the other side. It's done the same exact way, but that's the tools that I would use for doing something like this winglet fitting. So a ton of surface primitives, especially since they're all at varying angles from each other. Where, instead of going through tedious measurements of all those different angles by hand, we can just use that mesh to just pull that surface right from it. So the surfaces, the freeform surfaces, we can pull freeform surfaces right from the mesh as well. But yeah, that's the tool suite. That's what I got to show you. So if we go back and we look at our deviation from body again at the very end, I can check. I can probably fine tune that fillet, make it a variable fillet. But other than that, that's looking pretty good. So, all right. So I'm going to leave that right there. Anybody have this is the point where I got any questions about software capabilities? Anything think could have been done different? What do you think? You can go ahead and type them up in the chat. I'll take a look at the questions here and make sure there aren't any that have been hit I haven't hit on already. Okay. So I don't see anything that I missed. People typing up questions before the presentation. Again, I'll give you guys another minute here, just in case anybody comes up with a question. If not, I'll go ahead and let you guys get on with your day or your lunchtime, whatever you got going on here in the next few minutes. All right. Thank you guys for the compliments on the modeling. So definitely glad I gave you guys some points. Okay, so Michael asked, can you show the live transfer feature? So that guy, what he's talking about, if I go to File, Live Transfer to SolidWorks, it'll actually transfer the tree over to SolidWorks. I will say there are some differences in the way SolidWorks is, with surfaces, especially the way it trims things, the way it uses cuts. So I can't imagine this is going to roll through 100% smoothly, but I'll show you how it works. But if it actually, this opens up a SolidWorks, if you got SolidWorks on your computer, it'll open that up. So let's go to Live Transfer to SolidWorks. All right, I would say start from first feature, click the checkbox, and as long as you have it on your computer, it's going to boot it up and start transferring your features over there. So hopefully it opens up in the right window. While that's going on, let's see here. I saw a couple other things come up. Is this recorded? Yes, it will be recorded. So we'll have that sent out here. Could you share the link to the website? Yes. So if I go, let me copy that in right now. All right. So let's take a look at this while that's going. So this is what it does. It brings up SolidWorks and it starts throwing your planes, your sketches, and your surfaces, trims, stuff like that, all in your workflow. So here's where I expect it to have an issue. The way that the trimming works is a little bit different. So what I would need to do here, all right, so I've got my surfaces in here. I'm gonna go ahead and hide all of those planes. I would then do a insert surface trim, okay, and then I'm going to select my surfaces. Okay, I'll just do those three for now, and then I'm going to say keep sections. Oop. There we go. Okay, I think I did that right there. Oop. So you're doing your trims. I use Design X tools quite a bit more than SolidWorks. So some stuff I'm a little rough on for trimming, but the way that the tools work over here is a little bit different. But you trim it up. Once you got done with that trim, you're going to go right back over to your live transfer here. We'll do a file, live transfer. And again, we can go to a number of different features. So we have SolidWorks, NX, Creo, AutoCAD, Inventor. So we do have a number of software options to keep you guys covered. You say resume from selected feature. You go right to your mesh fit, click the checkbox, and the mesh fit's going to be a surface import, but it would just continue on with everything else. So it would bring in your lofted sections, things like that, and run through it. So there's a couple of features you do have to go through and make sure that they trimmed correctly, but that's that's a whole other workflow there. So I'm going to hide that guy. Okay, let me take a look here. Could you export without a tree to say master cam? So good question, Jose. So if we go to file, let's say if we go to a roll to the end of my model here, I'll show you we've got a huge amount of export options. So if you just want to export the solid, which is what most people do, which is what I do most of the time. We've got we can go to iGestStep, XT, XB. So anything like that, we can go directly to CATIA V4, V5. You go to a KeyShot model if you want to do renderings. So those are a bunch of different options. Main ones we're doing iGestStep, Parasolid, and then CATIA. So we can export any of those files which you should be able to open on your end in another software. All right. And then for import options, we've got a bunch as well. So we can import and bring that up here. Close this down. Okay. So if I were to go back to import, we've got again a gigantic list of files we can import. So if your 3D scanner or CAD program can make it, the chances are is we can use that. This software also has direct scanning. So if you've got some older scanner models, maybe that don't do their own processing, we have a live capture function as well. So you can scan and model directly into this software. All right, let's see here. Oh, thank you, Manny, for posting the link to the website. All right. Okay, I think that is everything. Looks like it. So any real quick last minute questions? Otherwise, I'll go ahead and let you guys go. All right, sounds good. Well, thank you very much. Again, if you got any questions for me, you can reach out at the beginning of my email at the beginning, kenny@neometricstech.com. If I want to show that again here. All right. So you can reach me at either that phone number, 47687-6202, or kenny@neometricstech.com with any additional questions outside of this presentation. So yeah, thank you everybody for joining us. Had a great time. Have a good lunch. Have a good rest of your day.